Okay, so this is lab 4, limiting reactants. We're going to be doing 2 reactions. One's going to be a precipitation and the other one will be redox. You will find the limiting and excess reactants for both. So first step, we're going to take this lead 2 nitrate and we're going to weigh out approximately 0.5 grams of it. Slower. Okay. So the amount exactly of lead nitrate that we're going to transfer to the beaker is 0.502 grams. So transfer in. Okay. That's good. Okay, and we're going to do the same thing with the potassium iodide. So get a piece of paper. I'm going to use a different one since I had a little bit of excess on that. Place the paper on the scale. I'm just going to and tear 0 it so that the paper isn't counted. And now you do the same thing, just a little bit at a time, and we're still doing 0.5 grams. It's going to be quite a bit. These are more of crystals. It up a little better. Oh, we're close. Okay, crystal. Oh. Yeah. These crystals are falling on this side. Okay. So the exact amount of potassium iodide that we are going to have is 0.515 grams. It is. Okay, so now we're gonna add 75 mLs of water, this DI water, to each one. We're gonna use a graduated cylinder to get approximately 75 mLs in here, and then I'm gonna put 75 into each of the beakers. Oh wow. Okay, so I got 75 mLs of water. I'm going to add it to each. So first I guess I'll do the potassium nitrate. And I'm going to use a stirring rod to stir until it dissolves. So then I do 75 mLs into the other beaker. Do I have the correct amount? 75, the meniscus is at 75. So we do the same thing with the potassium iodide. Actually, I want to rinse this off before I stir with something else. Okay, do the same thing, stir with the potassium iodide. Oh, this one looks like it'll dissolve a little faster. Okay, completely dissolved. Okay. So now that they're both dissolved, I believe we heat them until they boil. Let me just double check. Okay, no, first we add the Ki solution to the lead nitrate solution. Okay. So now that they're both completely dissolved, we add the potassium iodide solution to the lead 2 nitrate solution. Slowly. Very slowly. Okay. Heat it to boiling for about 5 minutes, and then we're going to let it cool to room temperature. So some heat on. This is heat. This might take a little while. PBI2. This is going to be our new, where's the pen? So this is now lead 2 iodide, PBI2. So the second part, you take zinc, so it's like assuming zinc. You put it in a test tube, and then I believe you add, we have a large test tube, then we add hydrochloric acid, and then this basically just observe that reaction. So we have a large test tube. Let me just double check on part 2. Record fingers milligram, put that zinc into a large test tube, and then use the graduated cylinder to add 5 mLs of 6 molar HCl, and then record the observation. Okay, count it. So we weigh out 1 gram of zinc. Ooh, it's kind of off-centered. Little by little. Okay, we're almost there. Close. Wow, that crystal didn't add anything.
You're doing a good job.
Thank you. We're getting there. Almost there. Oh. Oh my goodness. Okay. So the exact amount of our zinc that we're going to add to our test tube is 1.001 grams. Okay, then we're going to transfer it to the test tube. Try and get this as much as possible. So we're going to transfer it into our large test tube. Okay. I'm going to set this over here. This is, I believe, yes, 6 molar HCl. 6 molar hydrochloric acid. Okay. So I'm gonna, first I'm gonna pour it into this separate beaker, some of the HCl, so that I can measure 5 ml. I'm just gonna record 5 mLs. Okay. Ready?
Yes.
Okay, so now I'm gonna add the 5 mLs of the 6 molar HCl to the zinc, the 1 gram of zinc, in our test tube. And then you can watch and record your observations. Okay, here we go. So you can see some bubbling and clearly something's happening. Your view. So cool. We let it boil for 5 minutes, and then we're going to cool it down to room temperature. and then record our observations. Okay, so we're gonna cool down our solution here, so that way we can get our precipitate will form back together, or will relax the, so it'll bring the crystals together. Heating our solution, it dissolved, and cooling it back down will recrystallize it. Let it simmer. It's really hot. So heating it dissolves and like separates them, and then cooling it back down, it'll bring it crystallize it. Okay, so now we're going to, let me get 2 cans here. I'm going to place the beaker in the ice to cool it down, crystallize. And we'll wait for that to get down to room temperature.
Easier for our camera.
Yeah.
Don't have to move the camera.
Okay, so after this is cooled, we're going to filter it out to get the precipitate. So what we do is we take a filter paper. What we're gonna do is, once we get the cone together, we can stick it in there and that will catch the precipitate. So I'm gonna fold this in half once. Fold this in half once. Fold it in half again. And now you kind of have this little cone shape, and then you flip out a side. And that makes a cone that you can stick in here. Straighten it out. There we go. So that way when you pour this through, the precipitate will be caught in the filter paper and the rest of the liquid will go through. Then we can weigh it after heating it in the oven. Before you weigh your precipitate, you want to know how much the paper weighs. That way you can subtract this weight from it once you have the precipitate in it. So I'm going to tare it and weigh the filter paper. Okay, it looks like the weight of just the filter paper is 1.506 grams. Like mind blown, that's so cool. Okay. So thermometer. Okay, let's see what it's at now. I'll put it in. It looks like it's still pretty warm. So I'm gonna wait a little longer. I'm gonna stir it. We're at room temperature now, Dr. Fard. Do you want me to take it out of the ice?
Sure.
Okay. Remove it from the ice. Oh, look how pretty. It's so pretty.
Yeah, it is, isn't it?
See the crystals here? It helped recrystallize, and those are definitely going to get caught in the filter paper now. Okay. So I believe now that it's at room temperature, it's just so cool. Now we want to pour it into the filter paper, so that way it catches and the liquid goes out. Okay. Gotta go slow because it has to filter out. Also, we're gonna overflow it a little bit. So if you were able to see up top here, you can see the crystals floating on top, and there's just water just dripping out the bottom. Stick. For the excess precipitate, what would you do would you just leave it? Before I touch the filter paper and move it into the beaker, I'm going to put on gloves because this is toxic material. I don't want it to go on my skin and absorb. So I'm going to use gloves as a precaution before I put it in the oven and touch it. So I can get the glove on. Okay. So I'm going to take filter paper. I'm going to place it in the beaker. And now I'm going to put it in the oven. Put on the top shelf. And then when I take it back out, I'll use the beaker tongs because it's going to be hot. It looks like,
130?
yeah, a little, it's at the
135.
135 degrees Celsius.
Perfect.
So the oven is at 135 degrees Celsius. Okay, so this is the zinc with the HCl that I had earlier. If you touch it, you can tell it's not hot anymore. And you can see that it's not really reacting. There aren't many bubbles. And there's a lot of zinc left. Okay, so we've let the precipitate sit in the oven overnight at 110 degrees Celsius. So now I'm going to use the beaker tongs and my oven gloves to get it out of the oven. It's very, very hot, so that's why we use this. Hopefully it's fully dry. Okay. Ooh, that's very pretty. So it looks like gold. Got it? So I'm going to set this down and let it cool down to room temperature before I weigh it. Okay, so now it's cooled down to room temperature, so we're ready to weigh it. I put a piece of weighing paper on it, so that way when I place the filter paper there, it doesn't contaminate or touch the balance. So I'm just going to zero it with the paper on it, so the paper isn't counted in the weighing. And now I'm going to place the filter paper with the precipitate on the paper. Try not to get it on the balance. Doesn't seem to want to balance. Okay. So let it weigh it. Okay. So the weight of the filter paper with the precipitate is 1.932 grams. Okay, so now you have values of the filter paper without the precipitate and with the precipitate. So you can calculate the mass of the precipitate itself. Then from there, you can calculate limiting and excess reactants after you've written out your reaction.